5, 4, 3, 2, 1, go! Another 2 minutes. You should have bet, people. All right, so can you guys explain what you guys did? Obviously, that just happened so fast. I didn't even have time to process what was going on the screen.
Oh, cool. Hello, everyone. My name is Wei, and this is my teammate Xiaojin. And we are here to demonstrate how to use a bot to automatically solve the Google RECAPTCHA, which is a Turing test, as you say. And as you can see, we have an automation part which will send the image from Google RECAPTCHA to the AI engine, and the AI will do the prediction, send the results back. So the automation will click on the correct squares, and as you see, it passed the Turing test.
So you mentioned that was luck. Just a little bit?
No, actually, our AI engine is really accurate. I have confidence.
Yeah.
But sometimes, when I say luck, it's because Google RECAPTCHA, we only target on the street sign. But sometimes Google RECAPTCHA doesn't give these kind of questions. That's what I say.
Wow, that was amazing. I mean, that was less than, what, 20 seconds? Let's bring our judges forward, Mr. Wang and Ms. Song, for you guys to make some comments about how they did, based off of your criteria.
Yeah, very impressive. The success rate is nearly 100%. Li Wei told me that he can attack the real Google environment, but today, as a demonstrate, they just attacking the non-production environment. Right. Thank you. Very impressive.
And Ms. Song, anything you wanted to add?
Okay, so I think maybe for the benefit of the audience, we can also talk a little bit about what's happening behind the scene to help the audience to understand a little bit more in depth what you guys have done. So maybe you can explain a little bit what you guys actually did. Right.
Oh yeah. So as I mentioned previously, my bot has two major parts. One is automation. The other one is the AI engine. And for the AI engine, it's all about object detection. And,
so what system did you guys use? What learning system did you guys use? And how did you do the training? And can you talk a little bit more about that?
Yeah, sure. Thank you. So the object detection system we use is called YOLO. It's a framework, the abbreviation for "you only look once." It's end-to-end prediction. So all the detections is compressed into one single pass. It has a very good accuracy and it's very fast.
Right, so it's one big neural network.
Exactly.
Right, and what's in the neural networks?
It's purely just convolution neural layers and max pooling.
And then fully connected layers at the end.
Exactly, for the yes.
Right. And then how did you do the training? How did you train the model?
So to train the YOLO network specifically for Google RECAPTCHA, we use transfer learning, and we labeled ourselves 1,000 images from that we crowd from Google RECAPTCHA.
So you download your crowd 1,000 this kind of images, and you manually labeled them.
Manually labeled. Yeah.
And then you use that for the training data to fine tune.
Yes, exactly.
The YOLO model.
Yeah, YOLO model.
And how long did it take you guys to
do training?
To do the whole project?
The whole from the beginning till the first work version is less than half a year.
And did you guys have any deep learning experience before the project?
Actually, no. We just started.
Right. So that's really impressive. So I think one of the amazing things is that I mean the team obviously is very strong. It's a great team. And even without deep learning experience, I think you guys learned a lot along the way, right? And then, with the learning and doing the experimentation, and then, you developed the system. It's very impressive.
Thank you.
Right.
Just for record, this is my teammate Xiaojin, and there's my other teammate Shen.
Yeah. Yeah, great. Congratulations.
So now what you're seeing on the screen is they're rerunning it again, so just so you guys kind of get an idea, because that was so quick, no one really got to see, right? Does anyone in the crowd have any questions for Lee Squared? Oh, right over there, guy with the orange lanyard.
What? How long the training took?
Thank you. For the training, as I said, I use transfer learning, and it's 1 hour. With the hardware we use is 1070 from GTI.
Any other? Oh, there's another hand right over there next to the man in the green. And if you could introduce yourselves too, that would be great. Can we get him the mic over there? Yeah, maybe introduce yourself and why you're interested in asking that question, so we know a little bit about you guys too.
Very nice demo. I'm the co-founder of authentication security startup, Paperwork. My question is that it looked like, how do you understand the question? It looked like you skipped some question for like looking for the vehicle. Because I mean, if you know the question, it's easier because you definitely have to, understand the semantic of the question there.
Actually, we only target on the street sign.
Okay, okay.
Yeah, but we only.
So how do you generate the model to cover other questions?
Sorry, can you say?
How do you generate your deep learning model to answer other questions for the storefront?
It might be a different. For the storefront, it might be just a image recognition problem. For the street sign, it's a object detection problem. It might be different. So to generalize it, we have to train another model for it.
Okay, cool. Thank you.
Anyone else? Anything? If you guys have any questions while you see what's going on here, feel free to raise your hand. No? Okay, we'll let you guys admire the screen for a little bit. Judges, did you guys have anything else to add?
So how did you decide to choose YOLO? Are there other systems that you were considering, or that you may consider to try out later?
We had, as you mentioned, we have a few options at the beginning, but we are more familiar with YOLO, and we think that YOLO has a good performance in regarding to the speed, and the accuracy is fairly good as well. That's why we chose YOLO. Yeah.
And now we have our judge, Mr. Wang. You're going to explain whether or not they were successful based off the 2 minutes and the 8-minute criteria.
Okay. It's very impressive. They just use 20 seconds, and for the successful rate, predicting. Okay. So the success rate is almost nearly 80%. Yeah. 80%.
See, they got it done so fast, we can't even figure that out.
I think one thing you can see is that it usually does pick out the street sign. It's just that sometimes the surrounding boxes, sometimes either it missed the column or sometimes it marks some of the surrounding environments.
Yeah, thank you for asking. Actually, when we, the thing is, how this thing works is we draw the bounding box, and then we predict, we did calculations in which square we need to do the click. However, here's a little bit problem. So you have to predict exactly the bounding box as the ground truth. If you miss a little bit, my calculation will click on the wrong part, which will give you a wrong answer. So it's a little bit difficult. So challenging.
So maybe there can be some further refinements.
Yes,
to
refinement to
right.
maybe as I said, yeah, you have to predict exactly the happy truth, otherwise the calculation might be wrong and then you click on the wrong squares.
Right.
All right, so they were successful.
Yeah,
Mr. Wang.
successful.
Okay, so we have something for you guys. Ready? You got